Hi everyone, this is Mrs. G.A. and today we're going to learn about proving how to prove that triangles are similar. So there's three different ways we can prove that two triangles are similar. The first one is called angle-angle triangle similarity theorem. So this one states that if two angles of one triangle are congruent to two angles of another, then the two triangles are similar. So notice that you only need to show that two are congruent, because if two are congruent, then just using logic, we can also assume the third will also be congruent. So just showing two is enough. The second theorem is called side-side-side triangle similarity theorem. So this one says if three sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. So you do need to check that all three sides are proportional. And the last one is called side-angle-side triangle similarity theorem. So this one says if two sides of a triangle are proportional to the corresponding sides and their included angles are congruent, then the triangles are similar. So remember, the included angles are the angles that are in between the two sides that you're showing are proportional. So here you only need to show that two of the corresponding pairs are proportional, but you also need this extra piece that the included angles are congruent. Okay, so let's look at some examples. Here we're going to determine whether or not the triangles are similar, and then if they are, we're going to state the theorem that justifies it. And we're going to also provide some evidence with our statements. Okay, so let's look at this first one. Here I can see that I have one set of congruent angles, and I know the second angle, so we can use the triangle sum theorem to help us find those third angles. So let's set up a little equation. So we can say 65 degrees plus 74 degrees plus angle I should equal 180 degrees. So that means that angle I is equal to 41 degrees. So here I can see that angle H is congruent to angle X, and I can see that angle I is congruent to angle V. So this is enough to show that the two triangles are similar. So let's state the order in which they are similar. So if I do HIG, remember we need to match the parts. So again, this is the symbol for similar. So H must go with X, so X has to come first. I corresponds with V, so V must come next, which means W goes last. So your answer might look different, but remember the angles that correspond must go in the same place. So make sure you have that. So here's our similarity statement, and remember our reason for that is angle-angle similarity theorem. Okay, so in the second one, let's see what information we have. One thing that we see is that we do have a pair of congruent angles because they're both 90 degrees, and also these are both the included angle. This one is included because it's between these two sides, so the twos that we know, and we would also call this an included angle. So we can make the statement that angle Q is congruent to angle T. So now all we need to do is show that the two corresponding sides are proportional. So I'm going to set up a proportion with my two shorter sides. So we can say 8/10, and then we'll do a proportion with our longer sides, 16/20. And we're going to see if this is actually an equal statement. So we can do this by reducing each fraction. So if I divide by 2/2, we're left with 4/5. And if I divide this by 4/4, we're left with 4/5. So we can see that two pairs of the corresponding sides are proportional. They have the same ratio. So that means that these two triangles are congruent. And this is by side-angle-side similarity. Remember, we showed that two sides are congruent and the included are proportional and the included angle is congruent. So now we need to make our similarity statement. So let's say we do PQR. We just have to match the corresponding parts. So P is at the end of the shorter side, so it must go with S. So we need to say S first. Q corresponds with T, so that means U must go last. And this is our similarity statement. Okay, let's try a couple more together. So here we are given two side lengths, and we know that this length is 6. But more importantly for this problem, we are told that these two sides are parallel. So since we have two parallel lines cut by a transversal, well, it's actually cut by two transversals, once here and then once here, we can actually determine that this angle is congruent to this angle, and this angle is congruent to this angle. We call those corresponding angles. So here, since I know that angle AED is congruent to angle ACB, so AED is congruent to ACB, we also see that angle ADE is congruent to angle ABC. We actually have two sets of congruent angles, which is enough to show that these two triangles are similar. So this would be angle-angle similarity. So now we need to name the angles. So we're doing the tiny angle on top and then the larger angle. So let's say I name the tiny one AED. We just have to match the corresponding part. So A actually corresponds with itself. E, this would correspond here with C. And D would correspond with B. Okay, let's look at example D. So here we are given information about two of the side lengths, but this angle, this pair of angles that we know is congruent, this is not included. So the included angle that we would like to know about would be here angle C and angle H. So unfortunately, this is not enough information to show, so we would say not similar. Again, if we knew that the included angles were congruent, then we could check to see if the sides are proportional, but here we don't know anything about the included angles, so we aren't even going to check the sides. Okay, let's try example E. So here we are given three side lengths that we can check to see if they're proportional, but I don't even need to check those because we do see that we have two pairs of congruent angles, so this is going to be a little bit quicker for us. So since we can make the statement that angle A is congruent to angle D and angle B is congruent to angle E, these two triangles are similar using angle-angle similarity theorem. And now we can name the similarity statement. So let's say I do ACB. A corresponds with D, C corresponds with F, and B corresponds with E. Another way we could do this problem is we could actually compare the proportions of the three corresponding sides, and they should all be equal, which would be another way to prove that they are similar. Okay, in this last one here, we have two pairs of sides that we can test for proportionality, but then another thing you might notice is that here we have vertical angles, which we know are always congruent. And fortunately, these are the included angles, so this might be side angle side similarity. So now we just need to check the sides, but I am going to make that quick congruent statement. So angle BCA is congruent to angle DCE, and these are included angles because, again, they're between the two sides that we know about. So now we're going to check the proportions of the sides. So I'm going to match up the two shorter lengths. So I will do BC and DC, and we'll see if that's equal to AC over EC. So plugging in the values we know, we would have 3.5 over 5.6 should equal 5.5 over 8.8. So this leaves us with 0.625 equals 0.625. So the ratios are the same, which means that the corresponding pairs are proportional, and that means that the two triangles are similar. And again, this would be side, angle, side similarity theorem. And now we just need to do a quick similarity statement. So we'll start by naming one of our triangles. Let's say ACB is similar to triangle. I know that A corresponds with E, C corresponds with itself, and B corresponds with D. So that's our similarity statement. Okay, that is all for today's video. Thank you so much for watching.